Hello, my name is Ben Heald, and today I'll be speaking about security issues inherent in the popular backend server Parse that endanger over 60 million users. A little bit of background information about myself. I am a current computer science graduate student at RIT, and I have been involved in bug bounty and security research for over 3 years. I was also a member of RIT's national CPTC team in 2019, where we placed second in the competition. And just a fun fact about myself, in 2012, I wrote my first Python script on a Raspberry Pi to give away Dogecoin. I first discovered Parse while reporting a bug bounty to a Fortune 500 company on HackerOne. I learned that the security issues on the platform were inherent to Parse itself, and have been researching it ever since. A few months ago, I published my research into Parse on my blog, and I'm really excited to be able to share those results with the industry here at HacktivityCon. Parse is an open source application that provides a simple, class-oriented API to mobile application developers. Parse originally existed as a subscription-based commercial service where developers would pay to have their backend services hosted by parseapp.com. At its peak, it is estimated that over 500,000 mobile applications were being powered by Parse. Purchased by Facebook in 2013, the commercial branch shut down in 2017, leaving behind a wealth of open source code. It is unknown exactly why Facebook decided to shut Parse down, but it is likely due to the rise in popularity of rival platforms and the difficulty in maintaining such a large hosting platform. Whatever the reason, Facebook kindly open sourced the code base of Parse, enabling its continued use. Because of its ease of use, Parse survived the shutdown, and mainly survives now as a self-hosted service. Parse is integrated with MongoDB, and can be deployed on AWS and Heroku with a single click. These integrations make it incredibly easy for users to create and deploy a production Parse instance. While the majority of Parse instances today are self-hosted, a few companies, such as back4app.com, continue to offer commercial Parse hosting. Back4app claims that they host hundreds of applications on their servers. In addition to Back4app, several smaller companies also provide commercial Parse hosting. Parse is not the only popular mobile backend framework. A more well-known piece of software is Firebase, which is maintained by Google. Firebase has long been the most popular mobile backend service available. As the security industry knows, Firebase instances have been plagued over the years with data breaches due to their use of insecure default settings. The use of default settings that create an easier environment for developers is the root cause of the security issues with both Firebase and Parse. Mobile application backend frameworks like Parse and Firebase fill a real need in the application development market. For front-end developers, creating a scalable and easy-to-use API can seem a daunting task. By developing with a framework like Parse or Firebase, mobile application developers can focus on the user experience that they excel at. Unfortunately, the ease of use of these platforms creates its own problems. Since the platforms make back-end development relatively simple, the developers end up not truly understanding concepts such as API security. This idea will be further explored later in this talk. A developer who wants to use Parse needs to simply use the many SDKs available for a variety of development platforms. These include Android, iOS, and JavaScript. The Parse maintainers have striven to create an SDK for almost every programming language and development platform. The core of Parse functionality lies in the simple-to-understand class system. All data within Parse is stored as instances of classes. In order to create and store a new instance of a class, the developer needs to only send a POST request to their Parse API, containing the fields of the class object they wish to create. Once inserted into the Parse database, the API will return the object's ID. This ID can then be stored by the developer to reference later by using GET requests. In the following requests, the ID is incorporated into the URL and the data is retrieved. The Parse API has many built-in features that allow third-party login integration with Facebook, Apple, and Google, password reset, searching objects through regex commands, and file upload. These features are widely used by developers and therefore represent a key entry point for security misconfigurations, as we will examine later on. All the functionality of Parse can be utilized through a GUI application called the Parse dashboard. This GUI makes it easy for developers to manage their Parse instances entirely through the application, with no arduous programming required. This allows front-end mobile application developers to maintain their database of user data quickly and easily. Unfortunately, this GUI does not attempt to educate the user on the many important design principles of API security. The problem with Parse is that while it offers developers an incredibly easy way to create a mobile backend server, no security controls are in place by default. In a new installation of Parse Server, any anonymous user can perform extremely sensitive actions. These include reading all data in every class, creating new instances, and modifying the data of any class. This is true of all classes in the Parse database, even clearly sensitive tables such as the default users class that is often used to store data such as phone names, email addresses, and phone numbers. Ease in which this can be exploited is examined by the following request. A simple GET request is all that is needed to retrieve all data from any given Parse class. In order to authenticate to most parsed instances, all an attacker needs is a Parse application ID. This is a public ID that can be found by examining the code of whatever application we're testing, such as Android APK or JavaScript file. In response to this GET request, the Parse server will return all data within the class to any user. A common mitigation some applications use is to require users to have valid authentication headers in order to read the data in any given class. Unfortunately, these can easily be obtained by running the application through Burp Suite, logging in, and retrieving authentication headers from your account. Another key feature of Parse that an attacker can use is the ability to search by regex pattern. Using the following post request, individual entries of the database can be retrieved. This could be used by an attacker to retrieve the data of individuals with high accuracy. The following request will retrieve all email addresses from the users class that end with a .gov. This example also represents the kind of sensitive information and impact an attacker could have if the system using Parse is breached. While Parse does have several utilities to limit who can access the data in each class, the fact that these are turned off by default means that countless Parse servers expose their data for all to see. This problem is exacerbated by the developers of Parse, who acknowledge the risk this approach brings to server security, but do nothing to properly warn developers. The document seen here explains what permissions are allowed by default, but it is almost hidden on a small subpage in the Parse documentation. The wording in the security section also does not properly portray to the developers the risks involved in these settings. In their desire to produce a developer-friendly environment, the maintainers of Parse neglect the fact that data security is a cornerstone piece of any software development. In addition to allowing anonymous users to read all data in every class, the default configuration of Parse also allows unrestricted file upload. This can be used by attackers to serve malicious files from the victim's domain, create advanced phishing attacks, or account takeover if the files are served from a central domain. Once the file is uploaded on the Parse server, anyone on the internet can access it, meaning that there is no access controls set up by default. The following is a simple proof of concept post request that will upload an HTML file named test to a default Parse instance. An anonymous user can send this request and be able to serve arbitrary files on the Parse server domain. The problem with Parse file upload is yet again exacerbated by developers of Parse. Concerns about unrestricted file upload have been raised several times on GitHub, but time and time again they've been dismissed as historical behavior and good enough for now. The question remains, therefore, what can Parse do to help their community produce secure instances? First, implementing a by-default secure access control policy for Parse classes would help developers to protect user data. This is reflective of the data security principle of least access. If the class access controls are set to allow global read, the Parse framework should warn developers, both over the command line and through the Parse dashboard GUI. Finally, enabling file upload controls in the Parse dashboard would help novice developers to easily limit the types of files that can be uploaded. In order to find if a given application is employing a vulnerable instance of Parse, only a few tools are needed. In the case of an Android application, security researchers can use an APK decompiler such as JADX to examine and determine if Parse is being used. Once the Parse URL and application ID are retrieved, a simple GET request, such as the one shown earlier, can be sent to determine if the application is vulnerable. I have created a simple Python utility on my GitHub that scans a provided Parse instance to determine whether or not it is vulnerable. Feel free to check it out by scanning your own instances of Parse server to verify whether or not your company is vulnerable. You may be asking yourself, how widespread is the use of Parse? By scanning the top 1,000 Android applications, I was able to discover dozens of vulnerable servers. After contacting these organizations, only 2 of them had reached out and begun fixing their security issues. As you can see, in only a day of scanning, I was able to discover Parse servers that expose the data of over 60 million users. This user estimation is based only on Android application downloads, and the real number of users' data exposed could be much higher, due to the same application also existing on the iOS App Store. These vulnerable applications exposed a wealth of personally identifiable information. This included information such as email addresses, phone numbers, full names, social media tokens, and home addresses. Using this data, a malicious attacker could severely impact the lives of the consumers. These data types underline the severity of these vulnerabilities, as corporations could easily be held liable under privacy laws like GDPR for exposing user data. Violations of GDPR are quite serious and could cost companies thousands of dollars in fines for each incident. Using the tool Shodan, we can see that Parse is used in at least 800 servers hosted around the world. While not all of these are vulnerable, it is likely that many of them are. Other Shodan queries could be used to discover more Parse servers, and this example likely only represents a subset. In order to detect if these servers were vulnerable, DNS queries would need to be done to detect the true domain of the IP address. From these, the mobile application it connects to could then be discovered. The application would then be tested as described earlier. In conclusion, the default security settings of Parse server endanger the data of millions. In order to protect consumer data, developers using Parse server need to immediately ensure that they have proper access control policies in place. In the long term, Parse platform needs to adopt a new stance of security for their platform, or security issues will continue to plague them. If you have any questions or comments on this talk, please let me know on my website or on Twitter. I will also be in the HactivityCon Discord after this talk to answer any questions as well. Thanks for listening.